Hey everyone, welcome back to Geshkatoon. My name, of course, is Devin. For today's video, we're going to be talking about part one of a three-part video series that we're going to be covering off the construction of my insulated in-ground pool, as well as the shipping container pool building that also has a change room and a pump room in it. So this project took me approximately 2 years to accomplish. The reason I wanted it insulated is because I absolutely hate the cold water. So yeah, let's get right into it. All right, so before we dive into the construction videos, let's first talk about an overview of this build. It is a 14-foot by 28-foot pool. It has a steady depth, only one depth of 5 feet deep. I'll be able to talk about that in a little bit as to why we chose just to have no slope and just one depth overall for the entire pool. Then, of course, we have our high cube 40-foot shipping container that I did modify in order to accommodate the pool building. So we'll be able to dive into that. We do have a concrete deck sitting area up here. Right now, obviously, everything's pretty messy and shut down because we're not using this area, given that it is the middle of winter right now in Canada. So, yeah, all right, let's get back into the warm and get over some of the slideshows here. All right, that's a little bit better, us being inside now. So now we can talk a little bit about the construction of the pool, or the design and the logic behind it. So first of all, the pool was actually constructed the exact same as a house foundation. That way, if I had to repurpose this later on to build a small granny suite, something like that, if we found that the pool wasn't actually being utilized, then we would be able to convert it in the future. So that was just kind of a safeguard against that. The other thing, as mentioned before, is that I absolutely hate the cold water. And if I was going to be swimming in this, I was going to have to be able to effectively heat it, because I didn't want to be spending a lot of money on an uninsulated pool trying to keep that water warm. Again, especially being in Canada, if we want to extend that swimming season, you really do have to heat the water. And the most effective way for me to be able to accomplish that would be to have the pool insulated and then just a nice solar blanket, something like that, on the top of it. So the pool, when I started researching into insulated pool designs, that's when I came across ICF, or insulated concrete forms. That's what ICF stands for. And that's a very common building practice now. We're seeing brand new homes go in. It allows for the foundation all the way up to regular walls. So because of my experience with working with a foundation in the past, in my previous home, I knew that I would be able to tackle this job. I knew that it was going to be something that I could do personally and I wouldn't have to hire that out. So we did wind up going with an ICF foundation type pool. And that is, then we just have a liner inside of it, and that's what actually holds the water. The reason we went with a vinyl liner for the pool was just, it seemed a lot easier just to install that liner lock, which you guys are going to see in part two. Part one, as stated before, is just going to be about the civil construction of the pool. So that's going to be the digging right up to the final pour to get the concrete decking put out around it. Part two will cover off more of the plumbing, liner installation, just general final pool assembly. And then part three is where we're going to dive into the modifications for the shipping container pool building, where then I can show you guys some of the insides and what we did with that, and some of the benefits and drawbacks of actually utilizing a shipping container in that way. So yeah, anyways, let's first of all get down into the construction of it. So this video, unlike more going on in the future, it is going to be a lot of photos, unfortunately, because I wasn't planning on putting this one onto a channel 2 years ago when I started this project. The YouTube channel is coming along later on, so we should have more video clips in the future. For this one, though, it is more of a slideshow presentation, but it does show you step by step how we were able to get it to the final pour. So let's get into it. The majority of the dig was completed by my Massey Ferguson front end loader. This was because the larger bucket allowed me to take large scoops of dirt to relocate them on the property. When I did run into boulders, I would utilize my little towable backhoe in order to pull those out, and then I could relocate them with the front end loader. I had to do the dig in more of an open pit mining style with a ramp that you would drive down to get down in to dig it all out, which does mean there's a little more backfill, but the overall benefit is being able to move a lot of soil more quickly. So we did it that way. Here we are getting to the full depth. Once we reached our desired depth, we installed our footings. So here are the footing forms going in. It's really important at this stage, since this is the foundation for the build, that we do measure to make sure that we are square. So you measure corner to corner on your footings to make sure that you actually did have the correct dimensions. After that, you install your rebar, complete with the dowels that go vertical to then tie it into the wall that would be running up as the wall of the pool. So here you can see that. The dowels are spaced quite closely together, and we did utilize 15 millimeter rebar for the footings. Traditional footings for a 6-inch thick concrete poured wall would be approximately 6-inch thick footing, approximately 12 inches wide. For this, I actually beefed my footings up more just to give me that extra caution. So my footings actually had a dimension of 9 inches by 18 inches wide, just to give me an extra solid base to make sure that there wouldn't be any shifting. After the concrete for the footings was allowed to cure, then we were able to remove the form boards and then start the first course of our ICF on top of the footing. For these blocks, we did have to tie the blocks to the rebar that runs within the ICF just to help prevent any shifting. You also utilize spray foam around the bottom of those blocks to help fix it down to the footing and prevent any leaking out from underneath the ICF block and the footing. After the second course of blocks was completed, that is the last course of blocks that you actually have to tie the rebar to the block. Then you're able to just click the rest together, all just like Lego, building them up, installing rebar as you go. Makes it really simple. After the fourth and final course of blocks was installed, we were ready to install our piping through the walls for any of the pool plumbing. As well, we had to build some framing to help support the walls during the concrete pour. You also have to brace the ICF on common seams to make sure that the blocks would not actually have a blowout and that the concrete would stay within the insulated concrete forms. Finally, in addition to the horizontal rebar that was installed with each course of blocks, we also installed vertical rebars that then had the 15 millimeter dowels connected that would then bond the concrete wall to the concrete walkway that would be installed once we are completed our backfill. It's the concrete walkway that actually acts as the support beam to keep the walls from bowing in or out, whether it was from ground pressure pushing in or water pressure pushing out. It prevents any deflection of the wall. Here it is right after we have just finished pumping concrete into all the ICF forms, and we're just going to let it cure now. The concrete within the ICF has been allowed to cure. Now I'm able to remove the braces that supported the forms and also apply a rubberized foundation coating before moving forward with installing my external sump pit, which would drain the water away from the footings. The external sump pit is simply a double-walled plastic culvert stood vertically with a concrete foundation poured in the bottom of it. Here I am attaching a dimpled membrane to the outside of the ICF foundation. This not only helps waterproof the system and keep the wall dry, but also protects the ICF during the backfill. Once the dimpled membrane is completely installed, we then move on to installing the drain tile around the base of the foundation to allow groundwater to be drained away from the footings. As you may have noticed, rather than using the traditional drain tile of a big O perforated pipe complete with a filter sock wrapped around it, I actually use a drain tile burrito, which is perforated PVC surrounded in drainage gravel and wrapped in a filter fabric. The benefits to utilizing the drain tile burrito are twofold. Firstly, it is less likely to clog up because there is more surface area than the smaller size sock that would be wrapped around the Big O. As well, this system can be roto-rooted in the future should there be any blockages that are formed. After the drain tile was connected into the sump pit, it was time to begin backfilling. The first layer of backfill on top of the drain tile burrito was just more clear drainage stone. This just helps to keep the system clean. After that, I do another layer of filter fabric, which then on top of, I place granular A aggregate. To avoid issues regarding soil settling, every 6 inches of granular A that was put into the backfill, it was then plate tamped to ensure uniform compaction. Anywhere where concrete was going to be poured that required a structural base, granular A was used for that base. However, as a cost savings measure for the tapers to build from the grade level existing up to where the concrete deck would be, we did use the cheaper bank fill from our local supplier. Unfortunately, as we were getting really close to finalizing the backfill, the Massey Ferguson did wind up dying on me, and I just had to sell it for scrap parts. And unfortunately, I then had to rent a piece of equipment from Home Depot in order to complete the remainder of the backfill. With the backfill now complete, it was time to start constructing the forms for the final concrete pour for the upper level decking, as well as the shipping container pool building footings. Backfilling the inside of the pool was completed, utilizing drainage stone and granular A to reach the top of the footings, where then insulating board was used, complete with a plastic barrier on top of the silver board. Rebar rather than remesh was used to reinforce the concrete in the bottom of the pool as well as the upper decking, as I prefer the greater structural support that the rebar would provide. Now we were ready for the final pour. Rather than trying to tackle finishing this amount of concrete on my own, I did hire an external company to do this. They provided a brushed finish on the areas that we would be walking and a smooth finish on the bottom of the pool. Here's an aerial shot from the day of the pour. As you can see, I did have a lot of excess concrete that we wound up putting just in between the two footings that would be supporting the shipping container pool building. Here's a shot with my thermal camera showing how much heat is actually generated by the concrete in the first 24 hours of the curing process. After the concrete cured, I was able to remove the form boards and we're left with a product that looks something like a pool. Don't forget to watch part 2 of this video series to see how I even got that shipping container up there, or how I accomplished this, digging the electrical lines in. Don't forget to like, comment, and subscribe, and we'll see you next time.